Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 168. Page 168, and today is our lesson number 125. Page 125. The problem that we're going to solve is problem number 116. It's the problem that we already did yesterday on day 123. We have already solved this problem 116, and yesterday I gave you a homework, and we are doing today the homework problem. This is homework. It is 116. Let's call it 116 bonus. Now here's the problem. It says P is the exact same wording. If you look at problem number 116 and read the problem with me, it says P is the product of integers 1 through 30 inclusive. No changes so far. The question simply is, what is the greatest integer k for which 2 raised to k as opposed to 3 raised to k, which is what we did yesterday. It is no longer 3 raised to k, it is 2 raised to k, for which 2 raised to k is a factor of p. All the work from yesterday is still here. I'm going to erase this thing now because it no longer applies, because this work was based on looking for the value of k where it is a power of 3, not 2. We're looking for what is the largest power that 2 can take and still qualify as a factor of this quantity here, p times some integer times 2 raised to k. Let's do it, shall we? And the n no longer applies. N is going to have a different value. That was from yesterday. So we're going to erase everything that doesn't pertain today. And if you're interested, if you have not watched yesterday's video, make sure you watch yesterday's video so that you can follow through it. Because I'm not going to go into that much detail that I did yesterday. I'm just going to simply solve the problem. So here we're looking for the powers of 2. Since we are looking for powers of 2, just give me 1 second here. We are only interested in even numbers, because all the odd numbers are, obviously by definition, odd numbers are so called because they cannot be divided by 2. So Rp, that is Rp, is equals to product of all the integers 1 through 30 inclusive, but we are not interested in all of them, 1 through 30. We are only interested in the even numbers. So here's your 1, and then times 2, times 4, times, let's not put this here as a p here, because p, if I put p, then I have to put down the space for all the others. I'm just going to put down list 2 times 4 times 6 times 8 times 10. So in other words, if the question says if p is the product of all the integers 1 through 10, what is the greatest integer k for which 2 to the k qualifies as a factor of p? In that case, the answer would have been 2 can be written as 2 raised to 1, 4 can be written as 2 raised to 3, 4 can be written as 2 raised to 2, 6 can be written as 2 times 3, so that's the first power here, 8 can be written as 2 raised to 3, and finally 10 can be written as 5 raised to 5 times 2. So we have 1 plus 2 is 3, 4 plus 3 is 7, and 8. So in this case, the answer would be 8, and p can be written as some value of n, some integers n times 2 raised to 8. And of course, we know what n would be in this case. N would be the product of all the odd integers. Not only all the odd integers, but in this case, here in this context, n would be 1 times 2 times 3 times 4 times 5 times 6. 6 is replaced by, we already used up 2, so this is your 6 times 7 times 8 times 9 times 10. You see? Here's your 1 times 2. 2 is replaced by 1 because we took out the entire 2. So we have to have a placeholder here for 2 times 3 times 4. 4, entire 4 is taken out. times 4 times 5 times 6. 6 is, we took out the 2 but 3 is left. Times 7 times 8, the entire 8 is taken out, 2 raised to 3 is all taken out. 8 times 9 times 10, and 10 becomes only 5 because 2 is taken out. That's your n. Let's change this to 20. Let's make it, let's go to the middle, let's go to the intermediate step. Now let's have 20. In the case of 20, the question is, what is going to be the largest power that we can have here and still have 2 raised to k as a factor of p? Let's do it. So again, 2, 4, 6, 8, and 10, and 12, 14, 16, 18, and 20. And 2 we already know, 2 can be written as 2 raised to 1, 4 can be written as 2 raised to 2, 6 can be written as 2 raised to 2 times 3, 8 can be written as 2 raised to 3, 10 can be written as 2 times 5. We already did that part. So that's 1 plus 2 plus 1 plus 3 plus 1. Now let's figure out the powers of, so here 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 3 is 7, 7 plus 1 is 8. That's how we got 8 before. 12 can be written as 4 times 3. 2 raised to 2 times 3. That's your 12. 7 will be written as 2 times 7. 16 will be written as 2 raised to 4. 18 will be written as 2 times 9, or 2 raised to 1 times 9, and 20 will be written as 4 times 5, so that's 2 squared times 5. So that's 2 plus 1 is 3, plus 4 is 7, 8, 9, and 10. So far we have 10 now. So now, before we had 8, so now the value of k is 18. If this was the question, if the question was p is the product of all the integers 1 through 20, inclusive, what is the greatest integer k for which 2 raised to k is a factor of p, the answer would have been 18. Let's continue. We're gonna do the 30 now. Let's do it at the bottom here, instead of erasing everything. So we have 22, 24, 26, 28, and 30. So now we are up to 30. 22 can be written as 2 times 11. 24 can be written as 8 times 3, which is 2 raised to 3 times 3. So we have 1 so far, 3 here. 26 will be 2 times 13, so there's another one. 28 will be 4 times 7, which is 2 squared times 7, so another 2. And 30 can be written as 2 times 15. So we have 1 plus 3 is 4, 4 plus 1 is 5, 5 plus 2 is 7, plus 8. Voila, k equals 26 in this example. In this case, k equals 26, which means if we were to combine the yesterday's work and today's work, we can say that p can also be written as some integer m, let's call it m so that it is different from this guy here, times 3 raised to 14 we found out yesterday, times 2 raised to 26. There is your p. That's it, we are done. That's all there is. And of course you can figure out the value of n in this context if you wanted to, like we did yesterday. And here, without the 3 part, just 2 raised to k, what's the value of n? You can figure that out, which is going to be the product of all the odd integers and all the leftover parts that are here. For example, here we have 7, here we will have 3, and so forth. You understand? I'll see you tomorrow, okay? Bye now.